This is just to look at some other scenarios that we can solve with our other trig functions. So let's say we have some angle measurement that's unknown, and it corresponds to the coordinate -3, 3 on a non-unit circle. So, and we want to find sine, cosine, tangent, cosecant, secant, cotangent. Now something to note is that all of these values relate to the unit circle. So sometimes students get in the habit of saying, well, that's x, that's y, so sine would be 3 and cosine would be -3. That's not true. Sine, cosine, all of these, always on the unit circle, and we talked previously about the domain and range of these values, and we can't go out to 3 with these sine and cosine outputs. So instead what we have here is this extended radius, and we need to bring it back to the unit circle. So let's see what's happening here. So we're at -3, 3. -3, 3. So we're over here at -3, and what's happening is we are ending up with a triangle where we have two even side lengths, -3, +3. So in order for that to happen, this is a triangle that we're familiar with. This would lead to that angle measurement of 45 degrees. So what that means is we can go to our unit circle. If I draw as best I can a smaller circle in here, not too bad, I'm just going to move this -3 outside of there. So where we're having this coordinate of -3, 3 on a non-unit circle, to go to the unit circle, what we would do is we keep that same angle and we keep that same terminal side. It's just now we evaluate it within a circle that has a radius of 1. So this is our 45, so we're dealing with that √2/2. Then we just need to get our positive and negatives right. So we have a negative x value, so that'll be a negative √2/2. And then positive y value, positive √2/2. And now we can go and plug in values for sine and cosine since we're back on that unit circle. So sine is the positive √2/2. Cosine is our x-coordinate, which was negative √2/2. For cosecant and secant, we're just using the reciprocal, so this would be 2/√2. And I just need to rationalize that denominator. So that would be a 2√2/2, which simplifies down to a √2, canceling out those 2's. Secant, pretty much the same thing is going to happen, it's just negative, so that'll be a negative √2. So same flip, it would be the same exact calculation with rationalizing and reducing down. Alright, tangent, we're going to take sine over cosine. So sine is √2/2. Cosine is negative √2/2. What this comes down to is positive divided by negative, so that's going to be negative, and then it's the same thing, which will give us 1. And in cotangent, we just flip that, which is also -1. So given that coordinate, we just have to scale it back down to the unit circle, and we can do that because they're the same distances that relates to our 45-degree angle. Alright, let's see what happens when we have one of the trig function values, and we have a restriction on our angle, and then we can find our other values. So this notation right here, this is giving us an interval that our angle can be in. This notation right here means belongs to or belongs in. So we're saying our angle theta belongs to this interval from 0 to pi/2. And notice with the parentheses that means we're not including 0, we're not including pi/2. So what that's telling me is if I go to my unit circle here, is that here's 0, here's pi/2 in terms of angles. So we are somewhere in here in terms of an angle measurement. We can land anywhere on that part of our circle for all these terminal sides that can have those angle measurements between 0 and pi/2. Now they're telling us that sine of theta is 1/3. So that's our y value. So if this distance is equal to 1, I'm just going to, as best I can, estimate about 1/3. But we're on our unit circle, so I'm going to just go over here and plot this point that is some unknown x value, but I know the y coordinate is 1/3. So what we have from that is we have that y value. They told us the angle where it's restricted to because there's another option over here, but with their restriction on the angle measurement, we know that's not the case and that we're over here. So we have our y coordinate. We're using a radius of 1 here. All that we're missing is that x coordinate. So in order to get that x coordinate, what we can use is the Pythagorean theorem. Because if I just drop that down, then I know I have this distance of 1/3. I have this unknown distance of x. And since it's a right triangle, we can just plug it in. So let's do some work to the side here. So we have x squared plus 1/3 squared is equal to 1. Notice this right here is that Pythagorean identity as well. We have cosine squared plus sine squared equals 1 squared. That's in there. Alright, in fact I should put the square there. Okay, x squared plus 1/9 is equal to 1. Subtract 1/9 from both sides. So that's a 9/9, so this will be 8/9. Take the square root of both sides. Let's see, in the numerator, that'll be the square root of 8. Oh, let's just get some review of reducing roots. Square root of 8, there's a few ways to go about this. I'll show you 2 different ways. What I do is I think about possible perfect squares that go into that number, which I know 4 is a possibility, and then we'd still need to multiply by 2. So with that, square root of 4 would bring out a value of 2, but we'd still have a 2 trapped underneath the radical. Another way to think about it is the prime factorization of that as a 2 times 2 times 2. And if it's a square root, you want to make pairs. So the fact that we have a pair of 2's means that gets to come out, but we still have a 2 trapped underneath. A few different ways to think about that. Divided by square root of 9, which is 3. So that gives us our x coordinate, which is cosine. The x value is 2√2 over 3. Alright, so now we can start filling everything in because we have sine and cosine. So cosine is that 2√2 over 3. So if sine is 1/3, then cosecant would be 3 over 1, which is just 3. For secant, we're going to flip, so 3 over 2√2. And then I'm just going to rationalize that denominator. So this will be a 3√2 over, we have that 2 on the outside, and then √2 times 2. √2 times √2 is just 2. So this is going to be a 3√2 over 4. And then for tangent, we're going to divide. So we'll have sine, which is 1/3, over cosine, which is 2√2 over 3, which is 1 over 2√2, and then rationalizing that denominator. Sorry, my pen stopped working there. So 1 over 2√2, rationalize that denominator, which will be √2 over 2 times 2, which is 4. And then for cotangent, we flip that, and I could flip this, and then I would just rationalize the denominator. Sorry, so many technology errors right now, but we're so close to being finished. So I could use that last version of it, but I would just have to rationalize the denominator again. What we could do is just use this one and flip that version of it. So that'd be 2√2 over 1, which is 2√2. So those are some different ways that we can find all 6 trigonometric functions given different values.